Okay, Anya, got this one sorted out, and definitely would say it's probably one of the most challenging exponential equation problems that I've seen, but it makes sense, and really we just have to be very square in our understanding of how to utilize our exponent rules. So, as we correctly did before, writing this out and how we write this equation, so we can see that it is going to be 4 times the square root of a is equal to 9 times the square root of b. And just like I sort of pointed out before, there is some tied connections to the square root and the 4 and the cubed root and the 9. Write that there. Yeah. Okay, first step we want to do here, definitely we want to divide by the 9, right? Because we're trying to isolate b. So let's go ahead and do that piece, divide by 9. And then as a resultant, what we can see, this is going to be 4 over 9 to the square root of a equals the cubed root of b. Then we want to cube this side, and again, to be able to isolate our b. So now we're in the final form of everything on the left-hand side that needs to be on the left-hand side, and we have successfully isolated b. So now we can write our final equation as we sort of move from this. We can see we've got 4 square root of a over 9 to the cubed root, or cubing it, sorry, not to cube root, but cubing that to b. All right, now we know a here is equivalent to 2/3. So let's go ahead and insert that piece there. So as we write this, this is now going to be written as 4, the square root of 2 over 3 over 9, and then we've got to cube this piece, again, is equivalent to b. Now, this segment right here, and let me just kind of go ahead and actually make this a different color, actually, maybe point out a little bit better. This segment here in blue, we have to use what we call root of the quotient here now. Root of the quotient just means that we're going to split up this square root term into a numerator and a denominator. So now what it's going to look like is we're going to have something that looks like 4 over 9, but instead that square root term, as we do that, is going to be the square root of 2 over the square root of 3. So essentially what we've done is we distributed that square root term into both numerator and denominator. So that's how we can effectively write that. Just think of it like this. If I have square root of 2 over 3, the same thing to write that is the square root of 2 over the square root of 3. So that's what we've done here, and separating those terms, and we're still having to cube all of this, and all of these terms still equal to b, right? So now that we've done this, and what we can do here, we know 4 and 9 are perfect squares, and so what we can do is we want to get them into the lowest base. And this helps us to, as we sort of multiply these terms out, and helps us to make it more manageable. So the 4 can be written as 2 squared, right? So 2 squared times the square root of 2. And then the 9 can be written as 3 squared times the square root of 3. And we're still cubing all of these values that we have here, still equivalent to b, right? So now at this moment, what we have to do is we have to distribute the cube. Well, even before this, I think what makes this even easier is I'm going to take these and shift them into the square roots, and instead of being in radical form, I'm going to make them into fractional exponent form. So now, and what I'm going to do is I'm going to write these again. So this is going to be 2 squared times 2 to the 1/2, right? So that's how I would kind of write square root of 2 over 3 squared times 3 to the 1/2, right? So now everything is in the same base, 2, 2, 3, 3, and we're having to cube all these values. And so now what I'm going to do is I now have to distribute this cube into each term and such. And so what that's now going to yield, in a way, is that's now going to yield 2 squared to the 3rd power is going to give me 2 to the 6th, right? Times 2 to the 1/2 to the third power is going to give me 2 to the 3/2, right? Over, same thing here, 3 squared to the third power is going to give me 3 to the 6 times 3 to the 1/2 times the third power is going to be 3 to the 3/2. Well, now, and again, everything's still equivalent to b here. Now that we're in the same base and we're multiplying these exponents, that means we're really adding these exponents. So what that's going to turn the top into, so 3/2 is the same thing as 1.5, right? So this is going to turn the top into 2 to 7.5 over 3 to 7.5, which is equivalent to b, which we said here, b is equal to ax, right? So this is equivalent to a to the x. Well, what this is suggesting, we already know a is 2/3, right? So what we can then do to rewrite this segment here, right? A is equivalent to 2/3, so we'll pull that a out here. And what that's going to show is a is 2/3, but they both share this 7/2 power, right? So that means we can multiply and kind of reverse this to the 7/2. So that's equivalent to a to the x. Actually, let me write these in different colors so that you can see that a little bit more clearly here. This is to the 7/2. This is to the x here. So x and 7/2 are the same value. And again, all of this is equivalent to b. So the answer, which is asking for what is the value of x here, right? The value of x here is 7.5. So yes, so that's what we're kind of doing. I kind of had a little lapse in my exponents and equations. I knew I saw a pattern over here with the 4/9 and having to do that. It just is the order somewhat matters in how you sort of progress through these things. But you can see this is definitely a level 5 problem, definitely quite challenging. You can see just my explanation of this is taking a little bit over 7 minutes to walk you through this. Don't worry. I mean, this is to see something of this challenge is very, very rare, but at the same time, you know, something to really sort of stretch your understanding knowledge of exponent rules and fractional exponents. So, hope this helps. I'll send this to you, upload it to YouTube, send this to you. Please let me know if you have any more questions. Thanks.